So, so related to this class, we've been talking about Linux in here, and Linux is named after its founder, Linus Torvalds. So why don't we call it Linux?
Because he didn't want it to be called Linux.
I don't know if that's necessarily true. I think it's more of a widely adopted that people have started calling it Linux. I don't know what he calls it.
Okay.
It's entirely possible he calls it Linux. So the point is who's right? The person who invented it, who calls it whatever they call it, or everybody who calls it what? You know.
If he calls it Linux, it should be Linux.
No, I would tend to agree.
If you made something and you said, I'm calling it this, and then everybody else started to call it something else, you'd be pissed.
Yeah,
wouldn't
but
you?
how long did he wait after that format of photo came out to tell people you're pronouncing it wrong? Because everyone was
He probably
pronouncing it
waited.
that way for years.
He probably waited until it became a big thing like it is now.
It was already a big thing.
The internet's been divided on this for I don't know how long. So he probably chimed in at some point and said, yeah.
When it was financially responsible. Some point he was probably able to.
I got an endorsement.
When did he come out and say that it was pronounced that way? What, like 2 years ago?
I don't know this off the top of my head. You got a Google machine in front of you.
So you have a Google machine in front of you. So here's a funny thing I read at lunch. So there was, I don't know if you guys saw it in the news. So there was one of Royal Caribbean's newest cruise ships was off the coast. It ran into a 120-mile-an-hour wind. We're like in a hurricane. The captain confined everybody to their rooms. Now the thing's limping back to shore. Like ceilings fell down in this thing. That was awesome.
So you're saying you wish?
I wish I was on that.
Okay.
Oh yeah, that would be awesome. But although it doesn't seem like what they're offering to do is like adequate. So like they're refunding the people that were on the cruise the full cruise price. Makes sense. I don't know what they're doing for the. I think they got. Well, they would have just left yesterday, so I think or Saturday. Maybe it was Saturday to Saturday. So they got 2 days. A free 2-day cruise plus a roller coaster. And then I don't know if they're refunding their flights and stuff, like all the travel somebody had to do out there. And then they're giving them like a 50% off voucher for a future cruise.
So you basically get another half.
But the people who were on this cruise booked the vacation for this time of year. I mean, a future cruise might not, especially after that experience. I'd be all about going. That would be awesome.
Encourage you to get
Seriously. So I actually had a similar experience to that once. We were on a cruise ship, and I was talking. I'm always hoping for those rogue waves because those are the fun ones. When like out of nowhere, like everything's calm, and all of a sudden you just get slammed by a 30-foot wave. So I'm in the middle of the dining room. I'm like talking to the people at our table about it's like, oh yeah, I've been hoping for one of these rogue waves. As soon as that came out of my mouth, we took a hit. It was awesome. People were dropping their trays. It was really good too because that was lobster night, and people were getting sick, so they kept leaving. More lobster for me. Takes a lot for me to get seasick. That thing's going down if I'm getting seasick. We're halfway sunk. What's this?
So like after it happened, you just like stand up and proclaim your parents' power over rope.
Right, I did. Tabby said I was embarrassing her. My wife says I embarrass her actually quite often. So
See, that's what you should do. You should make a cruise line. It's like thing that attracts people is like stuff happens. Like you get like a really crappy cruise ship.
well, yeah, it's kind of like storm chasers. Like like it's really cheap cruises because they literally go out during hurricanes.
Wednesday.
Yeah, no.
It was this weekend.
Chinese New Year is Wednesday. They celebrated it this weekend.
May 21st, 2013 was when he came out and said that it's jail.
No, it's today.
2013.
Is
This
it?
format has been out since '87.
Well, a real true to life Chinese person said it was Wednesday.
Google says it's today.
No. Well, hold on. But wait a minute. In China, is today Wednesday?
Oh, no.
I mean,
It's Tuesday.
that's a stretch, but it's close. Is today's Tuesday there?
Yeah.
Okay, so at 11:59 p.m. today, what time is it in China?
Still Tuesday.
Ah. Almost. That would have been awesome.
Maybe he just
Don't have
figured
that same
so, like,
power as you over
he said it was going to be pretty too out part. Maybe he'll just be drunk until Wednesday.
So I knew it was Year of the Monkey, but why is it Fire Monkey?
It's a fire monkey?
It's a
So the
fire
first 3
monkey.
days, so the 8th and the 10th are like a holiday.
All right, so let's start looking at some stuff.
Whatever.
Doing some gifs.
We're doing some GIFs. Right,
He
so-
uses that in between.
So the correct is
Jeff.
Jeff.
Yes.
Jeff,
Like
okay.
it's with a J.
I got it.
Peanut butter.
Yes.
I got it.
But he waited like almost, what, 20 years to tell people
He
that?
didn't like wait. He wasn't holding on to this information.
At the
like,
end of the day, does it really matter what you call it? It's just a picture.
Yes.
It's a picture nobody uses.
It's a picture that everybody uses. GIFs are like, look at Reddit.
Okay, fine. They use it because of the animation aspect of it. But I mean, it used to be a thing in web where if you wanted smaller pictures, people would use the GIFs. But I think I've always called them GIFs. But whatever, it doesn't matter. Whatever. So, but nobody does that anymore because our internet speeds are fast enough. Who cares? We'd rather have more than 3 colors.
I mean, GIFs now are not.
Well, no, right.
Quality.
Yeah. So I don't know. That's not an export format that I think is commonly used in like software development and stuff. I've noticed with PNGs, JPEGs. Nobody uses TIFFs anymore either.
Wait, what? PNG's pronounced ping?
Durr. Yeah, I mean, didn't you read all about that? It's the guy who invented it.
Came out last week.
He had a speech impediment and got his tongue pierced the same week. I mean, it was one of those weird bird flu that like late onset speech impediment plus piercing. Okay, so we're on chapter 4. And we're hopefully going to get to type in some code today. There was an exercise there at the end of chapter 3. Let's just read that real quick and talk about what we could have done. So when using a Linux-specific reboot system, the second argument, magic 2, must be specified as one of a set of magic numbers. So there's built-in special things, Linux reboot magic 2. Oh, okay. So these guys must have I'm guessing there's 4 or 5 numbers that you can convert to hexadecimal. I wonder if it's whether or not it shows like different graphics during boot, because there's like 4 different modes for Linux boot. You can have one that actually shows a graphic, one that does ASCII art, one that does nothing. I don't know what the other one is. That would be maybe my guess. It's kind of a stupid question, but whatever. Okay, so let's start talking about universal I/O. So we've already referenced that. We had a quiz on that, dealing with everything's a file. So there's some sample codes here. So here's again a refresher that there's 3 built-in file descriptors that we automatically have access to: 0, 1, and 2, standard input, standard output, and standard error. Here's the POSIX name for these, and then here's the standard I/O stream name for these. And where is standard I/O stream? Where would we find that? What's that related to? So POSIX is going to be the Unix standard, right? So we're going to see that at the operating system level. Where would we see the standard I/O stuff? I heard a very tiny voice from Wirt that I think might have been correct. It's from C. Yeah, so this is the standard I/O library from C. We looked at that last time, right? Hashtag include standard IO.h. So this is C's representation of these 3 streams.
Hashtag?
Huh?
Hashtag?
There's no way I said?
You actually include a hashtag. Like he's not
Yeah.
saying, like
Yeah.
hashtag whatever.
Well, yeah, I know.
Oh, was that like weird? Was that like weird phrasing?
No.
Sounds like you're trying to start a Twitter movement though.
Yeah, right here. Yeah, hashtag.
Everyone go tweet that right now.
Wait, wait.
We're gonna go get hashtag include standard IO trending.
All right. Let's see. Blah 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 blah. Okay, so here's our 4 system calls that we talked about. This is part of what, and we already kind of at the high level talked about these. We'll briefly talk about it again, look at code, because I prefer looking at code than reading paragraphs of crap. But at the end of the day, when we open a file, we get a file descriptor. So this is part of our I/O, universal I/O across POSIX operating systems. So we have a system call called open that takes the path name, any flags, and a mode for like read, write, execute, that kind of stuff. And this ultimately returns for us a file descriptor, which is like a unique integer. Almost think of it like a phone number of that file. You know, doing air quotes on the file. Even though there's a couple different versions of open, because not all of them deal with path names. Some of them are going to, well, actually, no, there will only be one version now. Why, if we're opening a text file versus opening something from the USB port versus opening something from a network interface card, why would every one of those need a path name when I open the file? So I'm asking the operating system. So this is a Unix call. This is a POSIX call called open. And it's always going to give me a unique phone number, if you will, this file descriptor that I could use to talk to this dude. We already saw there's 3 file descriptors built in, 0, 1, and 2. So any additional ones are going to be these new ones. Every single time I open something, whether it's a file, whether it's a USB port, or a network interface card, I have to give it a path name. Why is that? Why does that even make sense? It's related to universal I/O. In fact, it's exactly universal I/O. So everybody should be. Everything's a file. So everything's going to have a full path somewhere in the operating system, right? Even your USB port. Be like /proc/dev/ something, you know, and at the end of the day, it'll be USB 1 or something like that. That's going to look like a file, but it actually is how it. That's the full path of the actual device. All right, so open keyword gives us access to something through a file descriptor. Read takes in a file descriptor as well as a buffer. And what does a buffer usually mean? When we say buffer, how should we translate that in programmer speak? Yeah, definitely memory. Usually it's an array we're going to pass in. Here's a chunk of memory. Here's an array. Fill this. So when we go and read something, we're saying, I want you to read from this file descriptor. I want you to read the data into this buffer. And then count is going to be the maximum size that we'd want it to read. So for instance, if I handed a buffer that's 1,024 bytes big, probably don't want to tell it to read 2048. Why is that, Pebbles? All right, so if I hand the read function a buffer that's 1,024 bytes big, why would I not want to give it a count of 2048? Okay, true. And why is that a problem? See, I love this game. It's my favorite games. All right, so let's say you have a, how big are bathtubs?
What measurement?
Hold on, like
Is it a
gallons.
Is it a bathtub for you?
No,
or for me?
like what's an average bathtub? How many gallons is an average bathtub?
55.
55 gallons? All right, fine, fair enough. Okay, so if I, so Pebbles, if I have a 55-gallon bathtub, why would it be a bad idea to put 100 gallons of water in it? Yeah, the same reason, right? Okay, if I provided you a place to store stuff, to put, okay, it's 40 gallons?
I
Really?
think it's 55.
35 to 50.
Ooh, so exactly what I said.
Well, actually, you're above the high end. Price is Right says it. Price is Right or is Let's Make a Deal? Which is
Price is Right.
Price is Right. Price is Right says you're disqualified. No, I've seen it. Not only do I know how to jungle, I know how to Price is Right. So anyways, The idea is when we say to read, we're passing that read function, the file descriptor we want it to read from, so that unique ID. So this requires that we've already opened that, right? So we have the file descriptor. We have to pass it the bathtub. We want it to fill up with the data as it's reading. And then we're going to tell it the maximum amount of data we can hold at a time. So if we're passing it the 55-gallon bathtub, we're going to say 55 is the maximum I want you to read. If you can read more than that, pause and go ahead and return to me how much you read. That's what numRead gives us. So the read function gives us an integer representing the number of bytes that it filled into our buffer. Okay? So that's read. Write creates a file descriptor, takes in a buffer that contains, so we're dumping out the bathtub now, Pebbles. Okay, so we have our buffer, it's filled with data. Here's the amount of stuff that's in that buffer. Why do we need to provide the amount of things that are in this buffer? Oh, right, but if we were doing this in Java and I passed a 1,000 bucket array to something, would I have to tell it had 1,000 buckets in it? I would?
No, it would know already, but this doesn't know how to do that yet.
I could ask a Java array what its length is, can't I? So why is this a problem? What language are we working with here? Explain these parameters right here. Do we go back to Pebbles or are we just wasting time there? Want to try?
I already know I don't know.
Oh, okay.
You won't have last class until next week.
Last class won't be until next class, next week. Last class, next week, first week. Juggler. GIF. All right, Tim, tell me, explain those two parameters to me in main. Margin? I'm kind of going down a pecking order of people that are going to embarrass themselves. Also, people are good sports. I typically don't just randomly call up people.
The char star star is because you need to kind of define a chart so you can see those individual characters.
Well, what's the whole purpose? The whole purpose of the parameters that go into main is to solve what problem? Like, why might main take in parameters? Main takes in parameters in a Java array or a Java program, doesn't it? Why? What's the purpose of those parameters to main?
You can pass certain settings to the program, tell it to do different things.
Yeah, well, even more generically, command line arguments. In the Unix world, we might want to pass a program some stuff, some inputs for it to work. But just in the generalistic sense, a program can take in command line arguments. And those command line arguments, in order to read them into the program, are going to come in from main because all programs begin and end with main. So this is where those arguments come in. This is how we have access to them inside the program so we can read in those command line arguments. So why does it take two parameters here to give us those command line arguments, where in Java we just say string array args or string array elephant? If it's me trying to talk about this point in 250 when you learned about all the questions I'm asking right now. So why do we need two parameters to do this? We talked about this last class. Go ahead.
One has the number, the amount of arguments, and the other one has the arguments.
Okay. And why do I need two in C when I didn't need two in Java?
Same reason you talked about where you can have length of something.
Okay, so this guy, what kind of animal is this guy? If you were to give me a description of this, what would you say this thing is in C? String array. Yep. So that's a pointer to a pointer. So we have a character pointer that points somewhere in memory to the beginning of a list of character pointers. Right, so that's effectively a string array. A string array is an array of arrays, isn't it? Each element is an array of characters. That's what a string array is. So these are my values. This is my argument values. This is the number of parameters that were passed in. Because in C, we cannot ask a array how many elements are in you. We can maybe try to create a hack and try to figure it out. We can just start at the base address and start walking it until we like reach something that looks like it doesn't belong and make a decent guess, because we're just walking through memory, right? C gives us direct access to memory. So nothing keeps us from just saying, I'm going to start at memory address 100. I'm going to walk in 4-byte steps until I start hitting stuff that doesn't look like it belongs. If I'm storing integers and all of a sudden I bump into a character, probably off the end of the array. But that doesn't make any assumptions that the array is, well, that makes assumptions that the array is A, already filled, and also that it's next to stuff that's already filled. Bad to make those assumptions. So in C, we need to know how many things are in an array, because an array cannot advertise that for us. So going back here, when we call the read function, we're going to pass it the file descriptor. We're going to pass it the container that has the stuff. I'm sorry, we're doing the right one right now, correct? The right one. We're going to pass it the file descriptor. This is the file we're going to write to. We're going to pass it our container that has the bytes that we want to write. And then we're going to tell it how many bytes are in there. Because that guy is receiving this generic array that he doesn't know how big it is. So we need to tell him how big it is. Make sense? There's a high probability that turns up on a quiz soon. That idea. Okay, this is really a C versus Java type of example where C arrays can't advertise their length themselves. So we need to pass their length around so that people who are using those arrays know how long they are. All right, so after we try to write to this file descriptor, this data, this count, it returns for us the number of things that was actually written. Generally speaking, the hope is it writes all of them, right? But something bad could happen, or well, you'd have to handle it yourself. Yeah, this is a world that existed before exception handling. So you would have to look and see that, oh, num written was 4. I asked it to write 13. Why? What happened? And then you'd have to try to figure it out. Figure out, you know, did it run into bad memory? Was it that you thought your buffer was one thing? Like your buffer was actually, maybe your buffer was 13, but the count was 4, for example. Like the counter you thought you were supposed to use was a different counter, so you'd have to kind of diagnose your own problem rather than getting like a null pointer exception or something like that, which really doesn't necessarily exist in C, because when you read from a memory location, there's going to be something there. You're going to get some value. It might not be the value expected. It might not be the place in memory you meant, but you're going to pull a value in and be able to do something with it. All right, so that's write and then close, kind of self-explanatory. That closes a file descriptor, removing it from the system. Okay. So let's look at this guy. So this is a program called Copy.c. So if we're making a guess based on its name, it sounds like it's probably making a copy of a file and writing it out to another file, right? Okay. So we have so a couple things we're getting up here. So we're importing stat.h. Here's this, well, here's the thing that they say they use a bunch of stuff. I don't know if that's actually part of a Linux distribution or not. We'll find that out when we type this into something. And I don't know what that library does. We'll see it down here. All right, so now we have a couple of constants. That's what these guys are. This is a buffer size of 1024. So we're kind of defaulting our buffer size. We're going to read things in. We think about these as bytes. 1024 is 1 kilobyte. Okay, 1 kilobyte at a time. All right, here's our main. Here's our int argc. Well, technically, this is sort of C++ code. So this is char pointer argv, where this guy's an array, and it's an array of character pointers. So this looks, we're kind of seeing half of the evolutionary, this is the missing link that lives between, between C and Java. Or I guess C and Java is fair enough. So this is alternative syntax for that char pointer argv. Okay, we're creating a couple integers for our file descriptors. So we have our input file descriptor, that's the file we're reading in from. Our output file descriptor, this is the file I assume we're copying. We're going to read something and make a copy of it and spit it back out. And then here's our flags for when we open it. When we look at this guy right here, when we see a variable type that looks like this, chances are that guy's a struct. Okay, the alternative is it's something called an enumerated type, but we'll see what we stumble on here. But this guy's likely a struct, and it's something called file perms, and this is related to, we talked about CH mode here, change mode. I said like 755, 777, 744, completely made up stuff. I didn't talk about that at all.
When you were talking about changing the read-write and execute thing.
Right, so when we do ls-l, we see all this stuff over here. Yeah, we have a function called change mode that we can change the mode, like on blah.c. I can change it to 755 blah.c, and if I run that command again, notice that blah.c is a different read-write execute thing now. All right, so that's the mode of a file. Tells us whether this is read-write execute by the owner, read-write execute by the people in the group, and read-write execute by everybody else. So if the last digit was a 7, that's the most public you can make a file. Doesn't matter who owns it, everybody can read and write it and execute it. All right, so our file permissions for this file is going to be inside of this thing called mode. These are all just variables that we're building up. There's nothing in them yet. Here's our numRed, which is going to be a size type, probably under the hood, that's an int. All right, then we're going to go ahead and define our buffer. So this is going to be a character array called buff, whose size is buff size. Buff size is 1024. So this is going to create a character array named buff that can hold 1024 chars. Okay, now here's using some command line argument stuff. So it's asking if the argument count is not equal to 3, and they didn't ask for help. So commonly a Unix command, if I go in here and I do chmod -- help, it gives me the, oh, it's probably just -8 for that. Oh, yeah, so -- help didn't work, but it instead it just said that's an illegal option and told me how to use it anyways. Typically, -h or -- help both work, and they give you just the usage.
Well, it's still a word.
Of it. Well, yeah, because this is how it handled an illegal option. It just said, here are your options. This is what you should type in. I wonder if there's a -- help. No, not. Okay, so in any case, that's what this guy's doing here. It's finding out how many arguments do you have. This is a string compare. So this is built into the standard string library in C. So this is a function that compares one string to another string. So we're going to compare the string that lives at bucket 1 of argv. What do you suppose lives at bucket 0 of argv? So argument v is the command line arguments, right? What if I told you the command line arguments, the argument count, argc, will never be 0? It will always be at least 1. What do you suspect is always stored in bucket 0 of argv? Well, if we had the count of the number of command line arguments, then why would we need the argc? Why would we need that second parameter? Huh?
Is the help trigger for all of them?
No, no. You have a guess?
I guess like some sort of open or execute or something.
Okay. Well, it's always going to be a string, right? It has to be a string because we have an array of strings. So argv at bucket 0 is going to be a string of some type. Now, if you're a program and somebody just launched you, is there something that you might, at the very least, want to know? Oh, not a horrible guess. Wrong. Wrong, but not a bad guess.
The path where they are,
Who you should report to.
It's the program name. Name of the program. So in this case, it would be Copy.c. So a program is aware of its name. And keep in mind, that's actually somewhat interesting. Inside here, this guy is, because of the nature of C and C++, Java, the file name is always the name of the class, right? We don't have that equivalent here. So this code is completely ignorant of the name of the file. You know, that may or may not be a big deal. You know, like if Evan was walking around, he didn't know his name, we might not notice. But every now and then, your name is going to be handy, right? You know, too drunk at the bar. Like, like, who are you? Like, wait a minute. I got this.
Did you like my halftime show?
Oh, it was good. I did. Are those extensions you do for those?
Yeah.
They're homemade. They make them with all wheat pasta. All right. So, in any case, argv at bucket 0 will always be the file name. All right. So this is saying if there's not 3, let's look at bucket 1 to find out if the command they're asking is the help command. Okay, and this is saying it's equal to 0. So this tells us string compare actually returns an int, not a true or false. So it returns an int. A 0 if they're the same. Not 0. Actually, string compare will a 0 if they're the same. A something less than 0 if the first guy lexicographically should come before the second guy, which is very similar to alphabetically, but not identical. Because it lexicographically uses ASCII, basically the ASCII values. It doesn't look at upper and lowercase characters for alphabetical. So this says if they're identical to each other, then, this says if you didn't give me enough command line arguments or you asked for help. If either of those is true, here's we're going to throw this, it's a function called usage error, which is probably just going to format it and say, here is the way it should be used. All right, assuming we get past that, now we're actually to the stuff, the things that the program should do. So we're going to go ahead and open our input and open our output files. So here's our input file descriptor. We're going to use the open command, passing it the name of the file that we're opening. And we're doing this as a read-only file. All right, so that's the option for read-only. And that's going to be built into one of these dudes up here. Then we're going to say if input FD is equal to -1, that means there was a problem. You gave me a file name that didn't exist, that kind of crap. All right, so this is just error checking. For right now, let's just assume error checking is not a thing, so we can focus in on what this is actually doing. All right, so open the input file, which was the first actual command line argument that the user gave us. That is not the name of the file, but the first thing the user actually typed. So if the user is typing this guy, they might say copy blah.c to blah copy.c. That might be how they call this. This is argv at bucket 0. This is argv at bucket 1. This is argv at bucket 2. So that line that we just looked at is reading in blah.c as the input file that they're going to read in. And we're opening that file for read only. That way we don't possibly damage the file. Yep.
If you don't give it the full path, does it assume that you're working in your present?
Yes. Present working directory is the assumption. Okay. So that's our input file. Now we're going to go ahead and get here's our open flags. Let's see, what's this guy? Open flag is a int, I believe. It is. All right, so we are doing some bitwise ORing across the bar here. So we're gonna, so we're mapping create, read only, and truncate. I'm not even sure what that does. And that's going to give us a single int after you OR all those together, which is what we want our open flags to be. So this allows us to, this is called masking, is this technique. So we're saying we want our file to be created if it's not already created. We want it to be write only. And I'm not sure what otrunc means. Is that an atomic thing? So it's telling it what to do with the file when you first open it. I'm not sure what we're actually doing to it. Oh, I do know what it means. It's actually kind of obvious. So when you first open a file, we're saying that we want to basically get rid of everything that used to be there. We're truncating the existing file. We're opening this guy for writing. So if the file already existed, we're going to overwrite it. As opposed to appending to a file where if the file already had 5 lines in it, we're adding things on top of that. Okay, so we're truncating the existing file to nothing, and we're going to write only, and we're going to create the file if it doesn't already exist. We bitwise OR all these together, and that will create for us our open flags that we're going to be using when we open our output file. All right, file permissions for this. So this is read for user, write for user, read for group, write for group, read for other, write for other. Oh yeah, read, write. So this is so that's actually a pretty. I think that's 666 mode. Christian Roby. I'm pretty sure that is. Let me test that real quick. Yep. Yeah, I actually think that probably is an Easter egg. That's something that C guys tend to do. It's kind of
Pretty awesome.
Did you even get that, Pebbles? We just had a good joke here. You got it? Well, no.
Easter egg.
Yeah, we found an Easter egg. So this guy right here ultimately turns into the integer value 666 for the file permissions for this.
All right, so is it like Ready Player One? Do you win anything?
All right, so now we're going to open our output file. So we're going to open, here's the name of the file, which was in bucket 2. Here's our open flags, and here's the file permissions. So we're going to open it. If it isn't already created, create it. If it was already created, empty it, truncate it, and then it's going to be for write only. Here's our open flags that we just, or I'm sorry, our file permissions, which is going to be read write for everybody. Then this is the error checking to see if something bad happened. Now we're going to go ahead and transfer data. So as long as numRead is greater than 0, what does this line effectively say? Before I explain that line, let's make sure you guys are following along. I'm not just sleeping into the sun, I guess. What I have highlighted there, what is we're going to keep going as long as what is true. Not Abe. That's somebody who is less likely to just get it right. Go ahead. You should be insulted that I said you were allowed to answer. All right, go ahead.
Keep going until there's nothing left to read.
Yeah, we're going to keep reading until we finally have a numRead that is not greater than 0. It'll eventually be 0. That means we've run out of crap to read, right? So as long as there's still stuff to read, keep reading. Now understand that what I have highlighted right here ultimately will boil down to a number. Because we're actually doing an assignment here. This is one thing we run into in C fairly often, is this idea. A lot of things that I've taught you as bad programming practice is very common programming practice in older C code. Right? So we're actually assigning a value to a variable inside of this while loop.
Why though?
It's a common way they did it back then, save lines of code and stuff like that, I guess. Remember when I first started telling you about that? I said nobody's impressed when you save lines of code, but that's what they're doing here. This is a variable assignment, what I just highlighted there. Okay, we're setting the variable numRead, which was defined up here somewhere. Here's numRead, which is a size type. So it's basically an integer. So numRead is going to equal whatever's returned by our read function. When we pass our read function, our input file descriptor, so the file we're reading in from, the buffer we're reading into, which is 1024, we built that guy up here, and then the size of that buffer, which is buff size, which is 1024. So this will set numRead equal to whatever that guy returns. Then we're asking so this ultimately will boil down to the value of numRead. Is it read or read? You're the inventor. What's the?
Both.
Yeah, probably numRead in context. Yeah, it's probably numRead in context. So what I have highlighted there is ultimately going to boil down to the value of numRead. Even though numRead has been changed, we did store the value inside of numRead, a variable will get resolved to its value. So it resolved to numRead, then numRead resolved to its internal value, which is going to be the number of bytes that were just read. And as long as what's up?
In that part you have highlighted,
Yep.
the first one, it's numRead, and then you're calling read.
Yeah, here's a function.
Yeah.
That's a function call.
So no, like how you pronounce it, the one before is read, and the next one is read.
Oh yeah, that's definitely
Well, yeah, this is read.
Because you're currently doing it.
Right, and here's the number that was read.
Yes.
Oh, so that's correct.
Yes.
Okay. You're just agreeing with me.
Yes.
All right. Well, I mean, who wouldn't? I mean, it seems like you have pretty decent odds to just always agree with me without even looking into anything. I try to tell that to my wife, and she rolls her eyes. It seems funny. I have found that I'm always right.
She thinks differently.
Most of the time. Most of the time. All right, so here's our function call, which boils down to a number. We're going to store that number inside of numRead. So everything I've highlighted right here will ultimately boil down to the value of numRead, which will be a number. Then we're comparing that number to 0. If it's greater than 0, that means we just read crap. Now, the crap we just read, where is it currently stored? Based on what we've talked about today. So I just read some crap. Probably bytes of characters, but crap. All right? And because we're going to get inside of this while loop, that means I read some actual bytes. So that means num read actually was greater than 0. Where is the data that I read? Because what read returns for me is the number of things that were read. Where's the actual data live? Output FD. What's output FD? So the answer is no. So to identify is wrong answer. What is output FD? What kind of animal is that?
Yeah, it's a file path you
File direct. Okay, and what are those things? Where the file is. No.
You're asking what a file directory
It's a file descriptor is what it stands for. FD. But what is a file descriptor? Are you going to answer the same thing again? Because that one's not right. So you might want to flip a coin and pick a different route.
The descriptor is the 0, 1, 2.
It's the unique telephone number of this open file, right? It's how the operating system identifies this open file stream. All right, so that's our file descriptor. Not where the data is stored. So where's their data stored? In the buffer. Exactly. So we passed in this buffer here. So we're reading the stuff in. And the read function magically reads crap in from this file descriptor into this buffer up to a maximum number of bytes of buff size, and then spits out the number of bytes that it read in. Because you might have room for 1024, but you might only had 8 bytes to finish reading. So in which case you read in 8. Great, we're going to use that, but we didn't fill the buffer. You're just telling me how much of the buffer I need to read. So if we're inside of this while loop, that means that we have stuff inside of buffer. How much stuff? Num read amount of stuff that we then need to write out to our output FD. So we're going to call our write function to output FD. We're going to pass it the buffer. That's the stuff that we want to write. And here's how much stuff it should read from there. That's how much stuff's in there that I want it to write out. So even though buff is 1024 big, in our little example we just mentioned, we only wanted to write 8 bytes because that's how much we just read in. All right? And what's that question ask? It's another error checking thing, but clearly as a group we need to get better at understanding C code. So what is that if statement checking?
That it's exactly equal to what was read,
Okay, and why is that important?
because otherwise it's lying.
Otherwise it's lying.
Yeah, I don't see how you would need that line.
Remember up here we talked about what write returns. We even talked about that sometimes things can go wrong. So write takes in a file descriptor, the data to write, how much data it should write, and this guy is going to return the number of bytes actually written.
So
What does it mean if the number of bytes written is not equal to the number of bytes we asked it to write?
You lost that.
Something bad happened, right? So what does this guy right here say? This guy says, if what I tried to write was not equal to the amount I actually read before, that means I read in 8, I wrote 6, not good. Okay? I read in 8, I wrote 14, also not good. Make sense? Okay, that second one is called a memory leak. Right? If you write 14 to something that was expecting 8, that's a leak. That's the bathtub analogy thing where you put the 100 gallons into the 55-gallon tub, bad things happen. All right? So,
From experience.
well, actually, I can only fill a 55-gallon tub with about 4 inches of water. All right. There is a very high probability of a quiz on this kind of stuff next time. Okay, because all this stuff is things we've explained in the last 2 days, and you guys aren't, for many of you, it's not sinking in.
I'm so close to being done with my